Hello again, everyone. I'm going to continue with the notes that I started on the previous video. So if you can locate this example, it's at the bottom of the page you were just on. It says, write the equation of the tangent line to the graph of y equals 2x cubed plus 5 squared at the point negative 1, 9. So remember, if you want to write the equation, you need a slope and a point. You have your point, you just don't have your slope. And if you want to find your slope, you need to use the derivative to do that. So we need to find the derivative of this function. So we're looking for y prime. This is another chain rule example. So we're looking at the derivative of the outside, which is 2 times 2x cubed plus 5 to the first power, which you can just leave. If you want to put a 1 there, you can, times the derivative of the inside, which is 6x squared. You can simplify this a little more, which is going to make things a little bit easier rather than having to multiply a bunch of stuff. 2 times 6 is 12, so you've got 12x squared times 2x cubed plus 5 as your derivative. And we're looking for the equation of the tangent line at this point, and this is when x is equal to negative 1. And so if you can use this information, remember your tangent line intersects at that same point. And so you're looking for what is the slope at that point. And so you need to plug in a negative 1 everywhere you see an x. So we're looking for y prime of negative 1, which when I plug negative 1 in, we're going to get this. Looks like that. You can simplify that just a little bit more. 12 times 1 is just going to be 12. 2 times negative 1 cubed is going to be negative 2, plus we've got that 5 in those parentheses. So we've got 12 times 3, which is 36. And this right here is your slope at x equals negative 1. And so you have your slope at x equals negative 1. You have your point at negative 1. So you can write your equation of your tangent line in the point slope form, which is y minus 9 equals your slope, which is 36, x minus negative 1, which becomes x plus 1. And so that is how you do that one. If you flip to the next page, it says find the points where f has a horizontal tangent. Remember from last week, if we're looking for points, they want x comma y. So finding x is not good enough. We're going to have to do both. If we're dealing with horizontal tangents, we're dealing with when the slope of the tangent line is equal to 0. So we're going to keep that in mind as we do this problem as well. So again, slope of tangent line equals 0. That's when you have a horizontal tangent. So we have to figure out what the derivative of this is. So we're going to rewrite this before we do that. If I rewrite this, actually, I don't want to rewrite this. I don't want to rewrite this because this value is not a constant. If it was like a 5 or a 4 or a negative 1, I could, but I'm going to leave this as is. I am going to rewrite it, though, using a power, I guess. So I've got x over 2x minus 1 to the 1/2. That'll just make things a little bit easier when I try to use chain rule. So, all right, we're going to find f prime of x, which is quotient and chain rule, similar to kind of the crazy problem we did yesterday. All right, so we've got low d high. So 2x minus 1 is my low to the 1/2. Derivative of the high equation, so derivative of x is just 1 minus high d low, so minus x. Derivative of this function here, 2x minus 1 to the 1/2, is 1/2 2x minus 1. That's the derivative outside, so we're using chain rule within the quotient rule here. So 1/2 2x minus 1 to the negative 1/2 times the derivative of the inside of this function, specifically in the denominator, which is 2. And this is all over 2x minus 1 to the 1/2 squared. So we've got low d high minus high d low over low low. That's where all this came from. And now we just have to simplify some things, which we can do. We did a similar problem to this the other day. So this is equal to 2x minus 1 to the 1/2 power. That's coming from this here. Minus x. I'm just going to rewrite this part here because I have a negative exponent and I can't have that. So again, remember, the only thing that gets raised to the negative half is the part that has a negative exponent. So this 1's going to stay in the numerator, so is this 2. So when I do this problem, I got to keep that information in the numerator. So I've got 2 over 2 times 2x minus 1 to the 1/2 power, all over 2x minus 1. When you take 2x minus 1 to the 1/2 and square it, 1/2 times 2 is simply 1. So I can leave it like that. And then I've got a complex fraction that I have to deal with. So I'm going to come over here to this other side. I've got 2x minus 1 to the 1/2 power. And this has to get multiplied by the denominator over here, so I can combine these two terms to be one fraction. And so I'm just going to write this over here so you can kind of see it a little bit better. So I'm going to take this times 2 times 2x minus 1 to the 1/2 over 2 times 2x minus 1 to the 1/2, because that is my common denominator over here, and I know I have to have a common denominator to combine these two fractions. So when I do that, 2x minus 1 to the 1/2 times 2, 2x minus 1 to the 1/2 becomes 2. 2x minus 1, these have the same base, so you have to add the exponents. 1/2 plus 1/2 is 1, so you can just leave it like that. And then I've got minus x times 2 over this, so minus 2x. And this is all over 2 times 2x minus 1 to the 1/2 power, all over 2x minus 1. I know it looks kind of messy, but that's just where we're at here. All right, multiply by the reciprocal, multiply by 1 over 2x minus 1. So we can get rid of that. And then you're just going to multiply straight across. And when you multiply straight across, I'm going to do a little simplifying when I do this. So I'm distributing this, and I'm going to simplify it from there. So 2 times 2x is 4x, and 4x minus this 2x is just going to give me 2x. 2 times negative 1 is just negative 2. So this whole thing is just 2x minus 2. All over 2 times 2x minus 1. This is 2x minus 1 to the half. This is like 2x minus 1 to the first. So when I add these two exponents, I get 1/2 or 3/2 as my exponent. You can factor from here. I may do that just because we're looking for when the slope is equal to 0, and that's going to make solving this a little bit easier. So if I factor out a 2 here, I'm left with 2 times x minus 1 over 2x minus 1 to the 3/2. And then this right here is f prime of x. And so I'm going to use that then to answer the actual question, which is, where does it have horizontal tangents? So it has horizontal tangents when your derivative is equal to 0. So I'm going to set x minus 1 over 2x minus 1 to the 3/2 equal to 0. And when I do that, I can multiply both sides by 2x minus 1 to the 3/2. So that's just going to be 0 when I multiply it times 0. So you're really looking at, when is x minus 1 equal to 0? And that's when x is equal to 1. And so in order to find the y value, which is your point, the y value, you got to go back to your original function. So 1 is your x value. To find y, you have to just go back to the original function and plug in 1. So that says x, or 1, over the square root of 2 times 1 minus 1. I'm getting that from right up here. That equals then 1 over the square root of 2 minus 1 square root of 1, or 1. So I have a horizontal tangent at the point 1, 1. All right. This next example, the last one, says find the second derivative. A couple different notations for second derivative. Anytime you see f double prime of x, that means second derivative. The other option would be derivative squared of y over dx squared. This means take the second derivative of y with respect to x. And you're doing it twice. So really, you're just going to find the derivative of this, and then you're going to find the derivative again. So when we look at this problem, let's first find f prime of x. This problem is set up to do a chain rule. So we've got 3 times 4, which is 12, times x squared minus 5 to the second power. That's the derivative of the outside, times the derivative of the inside, which is 2x. Simplifying that, I get f prime of x equals 24x times x squared minus 5 squared. So that's the first derivative. And then I have to use the chain rule and the product rule to find the second derivative. So if I'm looking for f double prime of x, notice that this is like a product here. So I've got product of these two, but this guy here is going to involve the chain rule. So product rule says 1 times the derivative of the second. So the first equation or first expression is 24x times the derivative of the second one. And that's where the chain rule comes in. So we've got 2x squared minus 5 to the first power times the derivative of the inside, which is 2x. So that's just simply derivative of the second function. Plus, back to product rule now, 2, which is the second equation, x squared minus 5 squared, times the derivative of the first, which is 24. So, not a super nice problem, but we'll get through it. All right, so we've got 24x, a 2, and a 2x. So I can multiply all three of those, which if you multiply those out, you get 96x squared. And then you still have that x squared minus 5 plus 24x squared minus 5. And I'm just going to simplify this as if this were a multiple choice problem, so you can kind of get the idea of what would happen once they go from this step to just a random answer that looks nothing like it. So if you notice, you've got an x squared minus 5 here, and these are two separate terms. So you can factor out an x squared minus 5, and both of these numbers here, the 96x squared and the 24, have a factor of 24. So I'm going to factor out, I want it to be red, it's not changing for me. I'm going to factor out a 24 x squared minus 5 from each of them because that's what each of these terms contains. So if I factor out a 24x squared minus 5 from this term here, I'm just left with 24 times 4 gives me 96. So I'm left with 4x squared. And then I don't need to worry about this because I already have it here. Plus, I already have the 24. I already have the x squared minus 5. This should be squared from up here. Whoops. So I need to add another x squared plus 5. So that's what I have so far. So from there, I can now factor out a 24x squared minus 5 again if I wanted to. So, oh wait, no, sorry. I already factored out a 24x squared minus 5. All right, let's see. What can I factor out from here? I don't think I can factor out anything actually, but I can combine these because those are both x squared. So I've got 24 x squared minus 5. These two combined, 4x squared plus x squared is 5x squared plus 5, like that. And so this is still probably not what you're going to see on a multiple choice test because this still has a factor that you can factor out. If you recognize that, you can factor out a 5 from there. And so let me come up here. We've got 24 x squared minus 5, and then I can factor out a 5, which leaves me x squared plus 1, which is not super nice still, but here we are. So then again, they're going to combine these two. 24 times 5 gives you 120 times x squared minus 5 times x squared plus 1. And I must have lost a sign here. This was supposed to be a negative over here. So that should be a negative. That should be a negative, which makes this a negative, which makes this a negative. Sorry, guys, I lost my negative. Okay, so the reason I noticed that is because I have my answer in front of me. This factors still. So we've got 120 x squared minus 5, x plus 1, x minus 1, because this right here is a difference of squares. And so this right here is probably what you're going to see on a multiple choice test. In terms of what you would have needed to do, like on your actual test, if you were finding the second derivative, I would have been fine with you leaving it at this step here. But if you have a multiple choice question on your test, this is what you're going to need to make sure you see. So just make sure you recognize that. Just a lot of factoring. I missed a couple of signs, so I apologize about that. But that's where you should end up when you are done. So thank you for sticking with me. It says check your answer in TI-84 by entering this. This finds the second derivative. I haven't actually tested this out yet. And I don't think your TI-84s actually are capable of doing that. They can only find derivatives at a certain point. So I'm not sure that you're going to be able to do this. But I always look online and just look for like derivative calculator. And you can usually type in your function and find it that way if you want to check your work. So that is all I have for you. What I would like you to do from here is worksheet 2 on 2.4, and then come with any questions that you may have for me tomorrow. All right. Well, that is it for today.